Okay, here is your solution video for the second mini assessment. So question 1, here are two rectangles. Okay, you've got rectangle A and rectangle B. All measurements are in centimetres. Find an expression for the area of rectangle B. So, of rectangle A, sorry. So rectangle A is this one here. We know that one side is 4, the other side is 3x plus 1. And we multiply them together to get the area. We can write that as just 4 3x plus 1. And then multiplying out the brackets gives us 12x plus 4. For part B, the area of rectangle A is equal to the area of rectangle B. Work out the perimeter of rectangle B. So we've already got an expression for the area of rectangle A, that's 12x plus 4. For rectangle B, okay, we've got 7 and 2x, so 7 times 2x is 14x. So the expression for the area of rectangle B is going to be 14x. We know that the two are equal, so we can put an equal sign in the middle. Now what do they want to know? They want to know the perimeter of rectangle B. So before we can find the perimeter, we have to know what the sides are. So we have to find x. So solving this equation here, first thing we want to do is get our x on the same size. Subtract 12x, we always move the smallest one. We get 4 is equal to 2x. Divide by 2, divide by 2, we get x is 2. Okay, so now we know what x is. Instead of having the side of B as being 2x, we can say that is 2 times 2, which is 4. If this side is 4, this side is 4, the top side is 7, the bottom side is 7. So to get the perimeter, we add them all up. 4 plus 7 plus 4 plus 7 makes 22 centimetres. Question 2. Make t the subject of 2d minus t plus 4t plus 7. Okay, so the first thing I see here is these brackets. We don't like brackets when we're having to rearrange or solve, so we are going to multiply them out. So multiply the brackets, you get 2d minus 2t is equal to 4t plus 7. Now if we want to make t the subject of the formula, then we do the same thing as if we were solving the equation. We want to get t to isolate t on one side and move everything else across. So again, I'm going to move the smallest one, which is the minus 2t. Opposite of taking away 2t is adding 2t, so add 2t to each side. You get 2d is equal to 6t plus 7. Now we want to get t by itself, so I'm going to get rid of the 7. Opposite of adding 7 is subtracting 7, so we get 2d minus 7 equals 6t. And now finally get rid of the 6, the opposite of multiplying by 6 is dividing by 6. We get 2d minus 7 over 6. I'm just going to write it down here. So we write it 2d minus 7 all divided by 6 is equal to t. Question 3. ABC is a right angle triangle, D is a point on AB, angle ACD equals 30, AD equals 10.4, DB equals 5.2, AC equals 18. Work out the size of the angle marked X. Give your answer correct to one decimal place. So the first thing I'm going to do is say, look, we've got all of this information here. Let me just double check it's on my diagram. So ACD, from A to C to D, so this angle here is 30. Yeah, we've got that there. AD is 10.4. Yep. DB is 5.2. Yep. And AC is 18. Okay. We're also told that it is right angled. We can see that already. And D is a point on AB. So we've used all of this information. It's on our diagram. We don't need to look at it anymore. So what do they want to know? They want to know the size of the angle marked X. So I want to know this angle here. Well, what I can see is that we've got a big right angle triangle, okay, ABC. We know that AC is 18, and we can find what AB is by adding these two together. So 10.4 plus 5.2 is 15.6. So this whole side here is 15.6. Now, if we were to find this angle, the big angle here, then we can take away 30 to get to what's left. So how are we going to do that? It's a right angle triangle, so we're going to use SOHCAHTOA. Okay, right angle trigonometry. So label our sides. Opposite the right angle is the hypotenuse, opposite the angle is the opposite. and we don't care about the adjacent. So using opposite and hypotenuse, we're going to be using sine. So we can say sine theta is equal to the opposite, which is 15.6, over the hypotenuse, which is 18. So then sine theta is equal to 0.86 recurring. Okay, leave that number on your calculator, use the answer function so you get an exact answer. Now to find the angle, okay, the opposite, use the inverse of sine. I'm going to have theta is equal to sine to the minus 1 of 0.86. And we get theta is 60.07. Yeah, 0.7. Okay, now remember that is the whole big angle. We don't want the big angle, we only want x. So to find x, we need to take away 30. 60.07 subtract 30 is 30.07. To one decimal place is 30.1. Ali has two solid cones made from the same type of metal. The two solid cones are mathematically similar. The base of cone A is a circle diameter 80, the base of cone B is a circle diameter 160. Again, a lot of information. We can see most of that already from the diagram. The most important thing to know is they're mathematically similar. So one is to get from one to the other, we can use a scale factor. Ali uses 80 millilitres of paint to paint cone A. Ali is going to paint cone B. Work out how much paint in millilitres he will need. So if they're mathematically similar, there is a scale factor times that you multiply by to get from one to the other. Now if we look at the length scale factor, because diameter is just a length, what have we done to get from 80 to 160? We have multiplied by 2. Now remember, the length scale factor is 2. That means that the area scale factor is going to be 2 squared, which is 4. So to find out how much paint he's going to need, because remember, if we're covering, to know how much he needs to cover paint, okay, because paint covers the surface area of the cone, okay, the space on the outside. So to know how much paint you use, it's proportional to the surface area of the cone. So we are looking at area, we need the area scale factor. So the area scale factor is 4, so 80 times 4. Oh, I do not know what happened there. So 80 times 4 is 320 millilitres. So he needs 320 millilitres of paint. Okay, question 4. At the start of year N, the quantity of a radioactive metal is Pn. At the start of the following year, the quantity of the same metal is given by Pm plus 1 is 0.87 Pm. At the start of 2016, there were 30 grams of the metal. What will be the quantity of the metal at the start of 2019? Give your answer to the nearest gram. Okay, so let's call the amount that got the beginning of 2016, P0 is 30. Okay, so then to find 2017, that's what we call an iterative formula. You plug your next value in, it gives you the next one. So in 2017, you're going to have P1, which is 0.87 times your first value, which is 30, P0, okay? When n is 0, n plus 1 is going to be 1. So 0.87 times 30 is 26.1. So at the beginning of 2017, there are 26.1 grams. 2018, we're going to do the same thing again. We're going to find our second value. So we're going to do 0.87 and use the value that we just worked out, 26.1, which gives us 22.707. And then we do it one more time to get 2019. Our third value is going to be 0.87. Use the last one you calculated, 22.707, which is 19.75. Okay, Then what do they want to know? They want to know it to the nearest gram. So to the nearest gram, rounding that, it's going to be 20 grams. And finally, a cuboid is pictured in the diagram below. EH is 4 centimetres, GH is 3 centimetres, and CG is 12 centimetres. Again, we've got them all marked on here already. And remember that as it's a cuboid, if this is 3, AF is also going to be 3, AB is going to be 3, DC is going to be 3, and the same for the other ones. There are lots of other lengths you can find. Now they want us to find the length CE, so that's this length here. Okay, a diagonal, 3D diagonal. So we can make a diagonal right-angled triangle, or a 3D right-angled triangle. Okay, our base of that triangle is going to be CF, our height is going to be EF, and then our hypotenuse is going to be CE, which we're trying to find. Now we know already that EF is 3 centimetres. We just need to find CF before we can find CE, because at the moment we've got two sides we don't know. If we think about the base of our rectangle, okay, so this side, this length CE is going across, sorry, CF is going across the base of our rectangle, we could make another right angle triangle using FG, GC, and CF. And once we've got that, we've got CF, which we can then use for these to find CE. So if I just redraw CF down here, we got CFG. We know that the base, or that this length here, CG, is 12 centimetres because it's marked on for us, we're told in the question. And the length of GF is going to be the same as HE, so that is going to be 4 centimetres. So to work out CF, we can use Pythagoras. We can say CF squared is equal to 4 squared plus 12 squared, which is 16 plus 144, which is 160. Now, in fact, I'm going to leave it as CF squared, because if we now think about CEF, our triangle, okay, I'm going to draw that triangle here. We've got CEF. Okay, we know already that this length here is 3, and CF is going to be the square root of 160. Okay, we can add that bit there if we want. But we can see again we're going to have to do Pythagoras again. Still looking for the hypotenuse, so we're going to have CE squared is going to be equal to 3 squared plus 160 squared, which is just going to be 160. So we get CE squared is equal to 169. So CE is the square root of 169, which is 13.